In this video, we will learn about arc length and sector area. Basically, arc length and sector area is related to circle. If we have a circle, then how can we calculate the length of one part of a circle? For example, if you will consider anything pie or pizza like things in a circle form, and if you will cut it a portion like that, if we have a pizza and we will cut it portion like that, and we want to find out the area or area of this cutting part, this is the part of a circle, then how can we calculate its sector area, or how can we find the arc length? So we will discuss all these things in this video. First of all, we have to remember one thing, that 180 degrees, that is equal to pi radians, right? And it will give us the relation between degrees and radians. So they can ask you, you have to convert these degrees to radians, and they can ask you, you have to convert uh, radians into degrees or degrees into radians. So from this relation, we will find the formulas of both conversion. If you want to find the degree, 1 degree is equal to pi divided by 180 degree. This will be divided here and it will be converted into radians. And if you want to find the value of 1 radian, then 180 degree should be divided by this pi and it will be converted into radians, right? So from this formula, 180 degrees, always remember, or you can write it in place of full degrees, you will write it denoted by a circle, right? Radians. So if you want to find the value of 1 degree, because 180 is multiplied by 1, so I will take 180 here, which will be divided here. So 1 degree is equal to pi by 180 radians. And if they will ask you 36 degree, how much 36 degree is equal to radians, then both sides you will multiply by 36, then 36 degree will be converted into radians, right? So in this way we will find the conversion of degree into radians. But if you want to find the conversion of radian into degrees, what we will do, I have told you earlier that this 80 degrees will be divided by pi, then it will be converted into 1 radian into degrees. So these are the conversion of degrees into radians. You have just to remember this statement, 180 degrees is equal to pi radians, and from this statement you can find the radians and degree conversion easily, or what is the relationship of degrees and radians, right? Next, I have shown a table here that 0 degree can be represented in radians in 0, and 30 degrees can be represented here by pi by 6. This is the conversion, right? After cutting they will give you this thing. And 45 degree can be written as pi by 4, and these terms in pi, this is in radians, right? It's in front of you. For example, if I have to convert this 30 degree into radians, so in this relation what I will do, I will multiply both sides by 30, this side and this side. When I will simplify it, it will give me pi by 6 in radians. So my 30 degree is equal to pi by 6 radians. In this way we made this table, right? If you want to convert it in radians, what will you do? If we have to convert, for example, 90 in degree, 90 degree into radians, then I will multiply both sides by 90, right? Here it will be 90 degree, and 90 and 180 will cancel each other, and they will give you pi by 2 radians. So pi by 2 radians, this table is formed in this way, right? And if they have given, for example, they have given you pi by 6 and they want it to convert this radian into degrees, what we will do, we want to convert it in degrees, what we will do, we will multiply pi by 6 on both sides. Pi will cancel each other, 180 by 6, they will give you 30 degree. So this conversion is come like that. So in both formulas we will apply the values and we will find the conversion of degree into radians and radians into degrees. I have shown you here. One I will show here. For example, you want to convert 30 pi by 6 radian into degrees, so you will multiply both sides by pi by 6. Pi will cancel pi, so the answer will be 30 degree. So pi by 6 is converted into 30 degree in this way. Use this formula, you can find this table, right? And you have to memorize this table also. The second way, if you want to memorize it, is that, for example, you know pi by 6 and you know what will be its answer. If I will replace pi by 180 degree, then 180 by pi, 180 degree by 6, it will give you 30 degree. Pi by 4 similar, in this way you will find the table, right? So you have to keep in mind that 0 will represent the value of 0 radian, but 30 degree will be represented by pi by 6, 45 will be represented by pi by 4, 60 by pi by 3, 90 by pi by 2, and similarly next table will come. Now all this is about the conversion. Now next thing is about arc length. If I will take a circle of radius r, this is r, anything will be radius, from anywhere you will take, it will be r same, right, in case of circle. So from this center O, I have represented it by O. This is one length is r, the other is also r, and it makes the angle of theta, right? And if I will represent this as arc length by s, if I will represent it by s, then what will be the arc length? It should be s is equal to this radius will multiply by theta, right, angle. So radius multiply by angle, that will give you one arc length. But you know, in case of a circle we have two straight lines, one straight line, sorry, if we have a straight line, but in above the straight line it is an angle of 180 degree, and if we will start our journey from here and we will go here, will be angle theta, but if we will go so on, the angle will become here, starting from 0, it will be 180 degree up till here, and when it will go back to 0, it will complete 360 degree, one round then completed, then it will be 360 degree, 180 plus 180, it will be 360 degree. So it is represented by 2 pi, because 180 degree is equal to pi and we have 360 degree, so it will become 2 pi. Pi value is equal to 180 and 2 pi, meaning 2 multiplied by 180, it will be 360, right? So if we replace, this is the arc length, length of only one portion of a circle, it's equal to r theta. But if we want to find the length of all the circle, this portion, all parts of the circle, if we want to find this length, then I will will replace this theta by 2 pi, right? If I will replace theta by 2 pi, then this will be equal to 2 pi r, and 2 pi r is the general form of a circumference of a circle. Basically, whenever you will consider about square, if one person start journey from here, this is the starting point, going there, then there, going there, and then come back. So this is called the perimeter of this figure square, right? It's called perimeter. But when we will consider this is the square, if I will take a rectangle, I will start journey from this point. I will go here, one side plus second side plus third side plus fourth side, and come back to the original point. Then this thing is called perimeter of rectangle, right? If it is 3 3 2 2, then perimeter will be 3 plus 2 5 plus 3 8 plus 2 10, right? This is called perimeter of a rectangle. And starting from here, if every side is 1 1, for example 1 1, or you will take 2 2 and 2, starting from here 2 plus 2 4 plus 2 6 plus 2 8. So perimeter of this square will be 8. In case of circle, when we will start journey from here and we will go along all the way of the circle, then this thing is called, in place of perimeter of circle, we give it a special name. This is called the circumference of a circle, right? So 2 pi r is the circumference of a circle. This formula we have to remember this in case of circles. Next, we have learned about sector area. If we want to find the sector area, then you know half r square theta is the sector area. Half r square theta will be sector area. But if I will replace again theta by 2 pi r, 2 pi, right? I have discussed here theta is equal to 2 pi. The whole rotation is here, one rotation. Then I will replace theta by 2 pi. 2 will cancel 2. Then whole area of whole circle will be pi r square. This is the important formula. How can we conclude it? This is the representation here, right? Hopefully you can understand it. So circumference of a circle is equal to 2 pi r, and we have calculated this by the arc length as we have shown here. And then sector area, if you want to find the sector area, this is the case of the, sector. In case of it's like a triangle. So sector area is equal to half r square theta, and when I replace theta by 2 pi, then I get the area of the whole circle, which is pi r square. So these two formulas are very important while we have to study the area circle related problem, circle related anything. So you have to memorize these three formulas. S is equal to r theta, arc length. S is equal to 2 pi r, which is circumference of circle. Area of a sector is half r square theta. But if we want to find the area of a circle, it is pi r square.